So here's some more homework problems from section 10.2, and these are pretty easy. We have the position vector given to us. You can see that right over here. R of t, that's our position vector, equals 3t squared, comma 2t cubed. This is the x position and the y position as a function of t. And if we want to find the velocity vector, we just take the derivative of each component of the position vector. So we just take dx dt and dy dt, and that's just going to be 6t plus and 6t squared. And that's going to be the x and y components of my velocity vector. And then if I want to take the acceleration, if I want to find the acceleration vector with respect to time or as a function of time, then we just take the derivative of each of these components, or the second derivative of these. Either case, the derivative of 6t is 6, and 6t squared is 12t. That's all you had to do. Pretty easy. On number 29, the same thing. Here's my position vector. So I just take the derivative, and then I have to use the product rule. So if I take the derivative of dx dt, this is my dx dt, or this is my x, pardon me, x has a function t and y is a function t. So if I take the derivative of x, that's dx dt, I have to use the product rule. First times the derivative of the second, so that'd be t times the derivative of e to the negative t is negative e to the negative t. Use the chain rule. So that was my x component of my velocity vector, the derivative of the x component of the position vector. And then just the derivative of the y component is just going to be negative e to the negative t. And then again, if we want to find the derivative of, if we want to find the acceleration vector, we just take the derivative of each component of the velocity vector. Pretty easy. So we just take the derivative of negative e to the negative t. So this was going to be, and that would be the second derivative of this. And this is going to be a product rule again. So I've got first, which is negative t, times the derivative of the second, which is negative e to the negative t. So that makes it a positive. And then the second, which is negative t times the derivative times the first, that gives me negative e to the t. The derivative of the first is negative 1, pardon me, negative 1. And that gives me e to the times e to the negative t. So derivative of the first times the second. And then I had the derivative of e to the negative t, which is just negative e to the negative t. So I got two of these, so I end up with negative 2. So we could write t e to the negative t and then minus 2 e to the negative t, and that's going to be my x component. And again, the y component is pretty easy. It's just going to be a negative times the derivative of e to the negative t, which is just another negative. So we end up with just e to the we just end up with positive e to the negative t. So that should be pretty easy. I mean, you shouldn't really even have to look at these. These are so straightforward. And then number 31, same idea. Actually, even a little bit easier because we don't have the product rule. This is my position vector. So this is my x component and my y component. And we just take the derivative of the x component. We just get the 2t. Derivative of sine is cosine. Don't forget the chain rule. 2t, and then the cosine is negative sine, so that becomes a negative times a negative is positive. And then we just have 2. Don't forget, again, the chain rule. The derivative of the cosine is negative. The sine of 2t times 2, so I put the 2 in front. And then if we want the acceleration vector, just take the derivative of the velocity vector, or the components. That's just 2. Derivative of the cosine is negative. Sine 2t, and then we have another 2 for the chain rule, so 2 times 2 is 4. And then 2 again, and the derivative of the sine is the cosine, but then we have a 2 because of the chain rule. 2 times 2 is 4. Okay, so pretty easy. I don't think there was much to those, so that should have been straightforward.